Okay, in this example, we are going to get into how you calculate the empirical formula of a compound. Now, the empirical formula of a compound is basically a representation of the lowest possible terms of the ratio of elements within a compound. So what that means is that, if we were to put it down into lowest terms, for this many calcium, how many chlorines? So the way that we determine that is we need to look at moles. We can't go from mass to mass because that doesn't actually tell you how many molecules there are of a particular compound. It doesn't tell you how many atoms there are. We need to work in moles and not mass. So we're told in this example that calcium chloride contains 1.82 grams of calcium and 3.23 grams of chlorine. What's the empirical formula for the compound? So we're first going to determine moles for each of these elements. So for calcium, we know that we have 1.82 grams, and if we look on the periodic table, calcium has a molar mass there, 40.078. So 40.078 grams per mole. And I am typing that into my calculator right now. 0.045411447 moles of calcium. We'll deal with all these decimal places shortly. Now we need to figure out the moles of chlorine. So the moles for chlorine, we're told that the mass in this sample is 3.23 grams. And if we look at the periodic table once again, we'll see that chlorine, the molar mass is 35.453 in grams per mole is our units. And that one there is 0.091106.535 moles. So we've determined the number of moles of calcium and chlorine, so that's both of the elements within this compound. Alright, so I've just rounded these off to a few decimal places just to make it a little bit easier to work with, but when we're doing an empirical formula, you could certainly keep all these decimal places if you have the space in your calculator to do that. So our next step, we need to find the mole ratio of calcium and chlorine, because that ratio is going to tell us ultimately the ratio of those two elements in this compound in their lowest or simplest terms, and that's the empirical formula. So to find that, we'll always start with the element that had fewer moles, and then we'll work in proportion to that. So we'll divide each of these numbers by 0.0454 moles. So for calcium, so that's going to equal 1 because anything divided by itself is 1. And then for the chlorine, 0.0911 moles divided by 0.0454 moles. And when we divide that, we are going to end up with an answer of, you actually get 2.006607932. We can just round that to 2. So that tells us that in this compound, even if we don't know its true identity, we know that the empirical formula is such that for every 1 calcium in the compound, there are 2 chlorines. So there's a 1-to-2 ratio, which means that the empirical formula in the end is CaCl2. And then we'll give a final therefore statement of therefore the empirical formula therefore the compound is CaCl2.